Today, we are going to discuss about efficiency of Otto cycle. In this topic, we are majorly going to discuss about two topics, that is Otto cycle and derivation of efficiency of Otto cycle. These topics come under the subject of IC engine. I am Dr. Naman Jain, Assistant Professor, Department of Mechanical Engineering. First of all, we are going to discuss about the different processes occur in the Otto cycle. First process is 0 to 1, which has been represented on PV cycle as shown here. Now, process 0 to 1 is represented by this line on the curve on PV diagram. This process represents suction stroke, that is fuel air mixture is drawn into the cylinder. So during this process, the fuel air mixture is drawn into the cylinder. Now, second process is 1 to 2, which is represented by this curve 1 to 2. In this process refers to reversible adiabatic compression process in which air-fuel ratio is being compressed by the piston when piston move from bottom dead center to top dead center. Next process is 2 to 3, represented by this line on PV diagram 2 to 3. In this process, heat is being supplied reversibly at constant volume. This process also corresponds to spark ignition and combustion in the actual engine. Next process is 3 to 4, which is represented by this curve on PV diagram. This process corresponds to reversible adiabatic expansion of piston when piston move from top dead center to bottom dead center. Next process is 4 to 1, which is represented by this curve on the line 4 to 1. In this process, a certain amount of heat is being rejected by the engine, which is represented by QR. Now, last process is 1 to 0, which represents the exhaust stroke in which exhaust gas is drawn out from the cylinder. Now, we are going to discuss in detail about different process in mathematical way and finally drive the expression of efficiency of Otto cycle. First process is 2 to 3, where heat is being added to the engine. The expression is being represented mathematically as mCV T3 minus T2. Next process is 4 to 1. This process represents heat rejected at constant volume. And mathematically, it is represented as mCV T4 minus T3. Now, if we talk about the thermal efficiency of Otto cycle, the thermal efficiency of Otto cycle will equal to mathematically equal to work done divided by heat supplied. Now the net work done is being equal to amount of heat added minus amount of heat ejected divided by heat supply, represented by this expression. Now, as we know that the expression of amount of heat added, that is QS, mathematically be mCV T3 minus T2, represented here. Now, the heat rejected, as we can see from here, the mathematical expression be mCV T4 minus T1. Now, finally, if we divide this expression with the amount of heat added, that is mCV T3 minus T2. Now, from this expression, we see that mCV is been the common part, and we can cancel out this by dividing with mCV. Now, in the final expression, if we divide T3 minus T2 with above part, then finally we get the expression T1 minus T4 minus T3 divided by T3 minus T2. Now, we are going to define compression ratio. Compression ratio has been defined as total volume divided by clearance volume. Now, total volume is been equal to V1 and clearance volume is V2. And we can also see that V2 is been equal to V3 and V4 is been equal to V1. So therefore, V1 upon V2 is been equal to V4 upon V3 and equal to R. R is the compression ratio. Now, next we talk about the process 1 to 2, that is adiabatic compression process. So adiabatic expression is T1 V1 की power gamma minus 1 is equal to T2 V2 की power gamma minus 1. And after rearranging in terms of temperature ratio, T2 upon T1 is been equal to V1 to the power gamma minus 1 divided by V2 to the power gamma minus 1. And we can see from the above that V1 upon V2 is been equal to R. Therefore, finally, the expression become R to the power gamma minus 1. Similarly, for process 3 to 4, that is adiabatic expansion process, similarly, as we seen from the above expression, in this process, the mathematical equation becomes T3 into V3 the power gamma minus 1 equal to V4, V4 the power gamma minus 1. And after rearranging this in terms of temperature ratio, that is T3 upon T4 is equal to V4 की power gamma minus 1 divided by V3 की power gamma minus 1, and that is been equal to R to the power gamma minus 1. Now, from above these two expressions, we can finally find that these two expressions, this one and this expression, these both expression are being equal to R to the power gamma minus 1. So therefore, T2 upon T1 is been equal to T3 upon T4. And after rearranging again, then T1 upon T4 is been equal to T2 upon T3. Now, the expression previously we have seen. Now we have doing that. We subtract this expression from 1. That is 1 minus T1 upon T4, that is equal to 1 minus T3 upon T3. And after solving that, it becomes T4 minus T1 upon T4, and that has been equal to T3 minus T2 upon T3. Finally, again rearranging them, and finally find the ratio of T4 minus T1 upon T3 minus T2, that has been equal to T4 divided by T3. Now we have find out this expression because in, in the mathematical efficiency of Otto cycle, we have found that previously we have seen that we have to determine the ratio of T4 minus T1 divided by T3 minus T2, and it has been replaced by T4 divided by T3 as we have seen from above expression. Now again rearranging this expression in this form, that is 1 minus 1 upon T3 divided by T4. And from previous expression, we have found that T3 divided by T4 is being equal to R to the power gamma minus 1. R is been the compression ratio. And finally, the expression of the Otto cycle comes out to be 1 minus 1 divided by R to the power gamma minus 1. Following are the references. Thank you, everyone.